Okay, so now we're going to look at XY independence in motion. So fun. So what we're talking about for XY independence, whenever we have pretty much anything in the class, all like velocity, we're going to talk about velocity today, but this works for acceleration and force and momentum and electrical field. It works with all that stuff that you haven't learned enough about yet. But what we're talking about is however much the x direction does not impact the y direction. Now I know what you're thinking. You're thinking, Mr. Keeney, that's just what independence means. And yes, I know. So what we're saying is, if you are moving to the right at 10, you could also be moving up at 3. But you could be moving to the right 10 up by 5, or up by 10, or up by 0. It doesn't matter. Each one of these will have a different vector of velocity. So this 10 and 3 one will be something like that, 10 and 5 will be something like that, and 10 and 10 will be something like that. 10 and 0 would be this one. So all of these vectors here have the same horizontal component, but different vertical components. But your x does not influence the y for any of this stuff. Alright, so we're going to do an example here. So we are in a boat pointed 70 degrees from downstream, going at 17 meters per second with a current of 8 meters per second to the right. So we're just looking for what's our final speed, okay? Notice its speed here, because I know we're still early in the year, and, you know, I mean, if you can call it early in the year, because has it really started? Alright, so what's your speed as opposed to velocity? We're not going to worry about the final direction here. We're just worried about how fast you're moving. So you've got a current of 8 meters per second to the right. So here's my river. It's going 8 meters per second that way. Now, our boat is pointed at 70 degrees from downstream. Downstream is going to the right. So my boat is pointed something like this. Alright, and it's going at 17 meters per second this way. And this angle right here is 70 degrees. Okay, so what we're going to do is we're going to add these together. Now, it's a little annoying to add them together because this is an x vector, right? It's horizontal. This is a diagonal vector here. So we can't add a horizontal to a diagonal. Well, you can, but you know, you need your geometry for that, and it's not worth the trouble. So what we have to do is we have to split the 17 apart into its component form, and then we can add them together. Because when you're going 17 that way, we're split it apart, so that means that it is going to be around 16. Hold on, I got it mixed up here. 16 this way and 5.8 meters per second on that way. So it's the same as if you're going 16 meters per second up and 5.8 meters per second to the side. Now what we can do is we can combine these two together. So I'm going to jump over to this open space here. So going to the right, now we have an 8 and a 5.8, which is going to give us a 13.8. And a going up of 16, right? These are horizontal and vertical, so it's a right angle. So we want to know what our resultant vector is. So putting them together, we're going to get just about 21 meters per second. And that is our answer. Ta-da! So the main ideas for today is you can combine the x's and the y's together. Or sorry, you can combine all the x's together, and you combine all the y's together, and then you stick them back using your vector addition. Alright? So that's the main idea here. So you throw a ball at 18 meters per second at 30 degrees from behind a truck moving at 25 meters per second. Alright? I'm going to help you understand the situation so we're all on the same page, and then we'll give you a minute to solve this, okay? So here's a truck as seen from above. Truck is driving this way at 25. You're standing in the bed of the truck, you're looking behind the truck, you're going to throw the ball, at 30 degrees from there. So here's a 30-degree angle, and you throw it at 18 meters per second. Okay, so here's the ball. Ball's moving this way. Now, if you're standing right here and you're going to go catch the ball, how fast is it moving? Should you be to the left, to the right? How fast is it going to be going? All right, so that's what we're going to figure out. Okay, see if you can pause the video and figure it out. Okay, so let's find out. So here we're going to break it into component form. It's at 30 degrees, so that's going to be a 9. This is going to be a 15.6 meters per second. Okay, so now combining these together, there's only one thing going down, so that's going to be the 9. Now the left and the right, we have a 25 and a 15.6. The 25 is going to be bigger than that, so it's going to be going this way. It's going to be going this way at 9.4 because we got to subtract them. They're going opposite directions. Now we figure out our resultant vector by doing L Pythagorean, which is going to be just about 13 meters per second. So that's how fast the ball will go in reference to the catcher here. All right. So we're going to do one more. It's just a ramp because we're going to do lots of ramps coming up when we start driving off of jumps and whatever. So you're driving up a 15-degree ramp at 45 meters per second. Okay. So how fast are you rising? All right, we'll give you a chance to pause the video. See if you can do both. I mean, it's a little easier than the previous one, actually, but we wanted to tie ramps into here because you're going to have to know them. All right, good job. So our ramp is going to look something like this. It's a 15-degree ramp, not drawn to scale. If you're driving 45 meters per second on this side, all you got to do is figure out what each side is. So we're going to do sine and cosine. So this one is going to be 11.6. So that's how fast you're going up because it's just going to be 45 times the sine of 15. And this one is going to be 43.5. That's this side here. Okay, there will be situations where you might have to figure out the angle, right? If I told you how long these pieces of wood were, you could figure out the angle by doing inverse sine, cosine, tangent, whatever. But it's the same general idea. You just might have an extra step up front. Okay? So this was all about the independence of x and y. This is going to help you a lot for tomorrow when we start doing projectiles. It'll be awesome. We'll see you then.